All right, let's solve another interesting question. You know, the other trapezoidal load that we considered in our first video, it was facing this direction. Is that clear? Just the inverse of what we have here. It was facing this direction. So what of the case that we have, what we have here, and you are asked to derive all the equations, that is, the equations for the reaction and the support, the shear force equation and the bending moment equations. All right, so for us to start with this, we are going to be taking the summation of forces in the y direction to be equals to what? 0. So we are going to take upward force positive and downward force negative. So if we do that, we are going to have this to be what? R subscript A plus R subscript B will be equals to, all right. So don't forget, when we have a trapezoidal load, we are having two loads there, which is the combination of what? A uniform distributed load and a uniform varying load. All right, so the first load that we have here is a uniform varying load, and from this point A to this point is W1, from this point to this point is W2. So the load on this uniform varying load is going to be W1 minus what? W2. W1 minus W2. All right, so we need to convert this uniform varying load to a what? To a point load. And how do we do that? It is going to be W1 minus W2 multiplied by what? L, then you divide it by what? By 2. All right, so we are going to have W1 minus W2. You multiply that by L, then you divide this by 2. All right, so plus, and we are going to convert this to a what? A point load again. That is W2 multiplied by what? By L. We are going to have this to be what? W2L. All right. So now this will be equals to, by the time we open the bracket, we are going to have this to be W1L minus W2L all over 2 plus what? Plus W2L all over what? 1. So this will be equals to the LCM of 2 and 1 is 2. 2 in 2 is what? 1. 1 multiplied by everything we have here will give us W1L minus W2L plus 1 in 2 is 2. 2 times this is 2 W2L. All right. So it means that we can therefore say reaction at A plus reaction at B will be equals to this will be equals to minus W2L plus 2WL. That is going to give us what? Minus 1 plus 2, right? So we are going to have this as minus 1 plus 2. We are going to have this minus this. That is, we are going to have this to be what? W1L plus W2L all over what? All over 2. All right. So if we factor out L from there, I'm going to have RA plus RB to be equals to W1 plus W2 into L all over what? 2. So let's call this equation number 1. All right. So now the next thing we are going to take is the summation of moments. So let's take the summation of moments about A to be equals to what? 0. All right. So we take the summation of moment about A to be equals to 0. We are still taking our upward force to be positive and our downward force to be what? Negative. So we are going to be saying RB multiplied by what? L. So we are going to have R subscript B multiplied by L to be equals to what? It's going to be equals to, all right. So now here we have a varying load. When we convert that to a point load, we have this, right? So and it's going to act at where? It's going to act at L over 3 away from what? Away from our A, right? So now this is going to be W1 minus W2 multiplied by L all over what? All over 2 multiplied by what? L over what? 3 plus, so when we convert our uniform distributed load to a point load, we have it to be what? W2L all over what? Sorry, W2L. So which is going to be multiplied by what? L over 2. It's going to act at L over 2 to the right, L over 2 to the left. All right. So if we continue with this, we are going to have R subscript B L to be equals to, If you open this bracket, you are going to have W1L minus WO, not L times L is L square. All right. So this is going to be W2L square all over what? 6. Then if we do this, we are going to have plus WL square all over what? 2. All right. So the LCM of 2 and 6 is what? Is 6. So we are going to have 6. 6 in 6 is 1. 1 times everything here is going to give us W1L square minus W2L square plus 2 in 6 is 3. 3 times this, we are going to have this as 3W2L square. All right. So by the time we proceed with this, we are going to have RB L to be equals to W1 L square, then minus W2 L square plus 3W2 L square. That's going to give us what? Positive 2W2 L square all over what? All over 6. All right. So if you factor out L square from there, we are going to have R subscript B L to be equals to what? W1 plus 2W2 into what? L square all over what? 6. So L will go with what? L. Then we'll be left with what? R subscript B. R subscript B to be equals to W1 plus 2W2 L all over what? All over 6. So that will be the reaction at what? At B. All right. So now, for us to get our reaction at A, we already have our equation 1 to be RA plus RB to be equals to W1 plus W2 multiplied by L all over 2. So here we are going to have our RA to be equals to what? This is going to be W1 plus W2 multiplied by L all over 2 minus what? Minus RB, which is going to be minus into W1 plus 2W2 multiplied by L all over what? 6. All right. So the LCM of 2 and 6 is what? Is 6. So we are going to say R subscript A will be equals to the LCM of 2 and 6 is 6. 2 in 6 is what? 3. So 3 times W1 multiplied by L, we are going to have 3W1L plus 3W2L. All right. So this is going to be 6 in 6 is 1. Then it's going to be minus 1 multiplied by W1 multiplied by L. We are going to have minus W1L minus 2W2L. All right. So that's what we are going to have. So it means that our RA will be equals to 3W1L minus W1L. That is what? 2W1L. All right. Then 3W2L minus 2W2L are going to have what? Plus 1W2L. That is W2L. All right. All over what? All over 6. All right. So we can further factor out L from there. So R subscript A will be equals to 2W1 plus W2 into what? L all over what? 6. All right. So that will be the reaction at A and the reaction at B. All right. So now the next thing we are going to be doing is our shear force calculation. So we are going to go for our shear force now. Shear force calculation. All right. So for us to do our shear force calculation, we are going to denote that with shear force, that is SF subscript E will be equals to, all right. So for us to do that, we are going to section this beam. We are going to section this beam. Let's section it at this point. We section it at this point. So from this point to this point A here is going to be S. All right, so if we section it at that point, now this is what we will do. So we are going to call this place to be what? W subscript S. All right, we don't know what W subscript S is. All right, so for us to do that, we are going to stand at this point now. Then we are going to take our forces. Upward force is what? Positive, and downward force is what? Negative. So it's going to be, this one is upward force. It's going to be what? It's going to be arrow A, right? So that's going to be arrow A. Then this is going to be minus the, if you stand here, what you will still have between this section line and this place is a what? A trapezium. So it's going to be minus the area of a trapezium. And what is the formula for the area for the area of a trapezium? It's nothing but what? Half into what? Sum of the parallel side multiplied by what? Multiplied by the height. So now the sum of the parallel side is going to be W1 plus what? WS multiplied by the height, which is what? S. So it's going to be half into W1 plus W subscript S, then multiplied by what? S. So that's what we are going to have. Now, the next thing is our WS. How do we analyze our WS? Now, look up. Now, we have two triangles here. So we have these bigger triangles, and then we have this smaller triangle, right? So we are going to be using similarity theorem of two triangles, right? So now we know that the height of this bigger triangle is nothing but what? Is nothing but W1 minus W2, right? And the height of this smaller triangle is going to be what? WS minus what? W1, because WS minus W2. From here to here is W2. So the height of this small triangle is going to be WS minus W2. So this is the height of this smaller triangle. The height of this bigger triangle is W2 minus W1 minus W2. So the length of this smaller triangle is from this point to this point. So from here to here is L. From here to here is S. So the length of this smaller triangle is going to be L minus what? X. So we are going to have L minus X here. So if we take the height and the length of this smaller triangle is going to be WX minus W2 all over what? L minus X. So we are going to say WX minus W2 all over what? L minus S. So we are going to do same for the bigger triangle now. So it's going to be what? It's going to be W2 minus W1, everything all over the total length, which is what? L. So we are going to have W1 minus W2 all over what? L. All right. So that is what we are going to have. Then we are going to be making our WS the subject of the formula there. So I'm going to clean this side. So the next thing we are going to be doing is if you make WS the subject here, I'm going to have WS to be equals to what? So it's going to be W2 and plus W1 minus W2 all over L, then multiply by what? L minus S. L minus S. All right, so that's what. All right, so that's what we are going to have. Now let's try and expand that bracket. Let's see what we have. So W subscript S will be equals to W2 plus, so if we open this bracket, we are going to have W1L minus W1S minus W2L plus W2S all over what? L, right? All right. So now the next thing is we find the LCM of 1 and L here. We're going to have our WS to be equals to the LCM of 1 and L is L, right? L. So 1 in L is L. L times this is W2L plus W1L minus W1S minus W2L plus W2S. All right. So if you look at this, W2L, we'll go with W2L. All right. So then we'll be left with WS to be equals to what? W1L, W2L W1L minus W1S plus W2S all over what? All over L. All right. So WS will be equals to, we are going to have this to be W1L. Then if we factor out minus and S here, minus into W1 minus W2, everything into S, all over what? L. So if we split L for the two of them, we are going to have W subscript S to be equals to WL divided by L. We are going to have W1 minus W1 minus W2 into S all over what? L. So that's what we are going to have for our WX. So take note of this. This is very important if you'll be using the formula. All right. So now we are going to substitute this in what we have here. Then we can now rewrite our shear force equation to be equals to what? It's going to be equals to R subscript A minus what? Minus half into what? Into W1 plus what? Plus W1, then minus what? Minus into W1 minus W2, then close your bracket into S all over L. Then you can close this bracket with S, with another S here. All right. So we are going to have our shear force equation to be equals to R subscript A minus half into W1 plus W1, that is W1, 2W1, multiplied by this S. We are going to have 2W1S, 2W1S, then S times S here is going to give us minus into W1 minus W2 all over L, then S square. All right, so that's what we are going to have. Now I'm going to clean this side. So now we can now replace our ROA with what we have here. Our ROA is 2W1 plus W2L all over C. So we can therefore rewrite our shear force equation to be equals to ROA, which is 2W1 plus W2L all over what? 6, then minus what? Now we can now open this bracket here. Half minus half multiplied by what we have here is going to give us what? Minus W1S, then minus half multiplied by minus, that is plus. So that is plus W1 minus W2, then S square all over what? 2N. All right, so that's what we are going to have. So this is going to be the shear force equation. You get that? Is either you use this first one, but in case you are asked to derive this, this is how to derive this. All right, so now but for our calculation, this you can just memorize the first equation that we have. You can just memorize just this. I think this is okay for you, since you are going to be given everything. Then you are going to memorize your WS here to be equals to this. Do you understand? All right. So but me, I don't like cramming. Do you understand? I love using analytical method to solve all of this stuff. All right, so this is our shear force equation. All right, so that now we can now get our bending moment equation now. So our bending moment equation. All right, so that's it. So our bending moment equation will be denoted by MS. So which will be equals to, now if you want to get your bending moment equation, you don't need to stress yourself. All right, the only thing we just need to do is this. Now we know that this is our ROA, right? All right, so this is our ROA. Our ROA is this, and this is the portion that we share, right? This is the section. So if you want to take your moment about this point, it's going to be ROA multiplied by what? By S. So we are going to multiply this load by S. We are going to have 2W1 plus W2 all over 6 multiplied by what? LS, right? Then minus, all right. We have W1S. Our W1S here, when we stand at this section, it means when you convert what we have here to a point load, it's going to be W1 multiplied by what? S, which is W1S. That is the point load from that side. And it's going to act at where? X over 2 to the right and X over 2 to the left. So we are going to multiply this by what? X over 2. So this is going to be W1S. That is multiplied by X over 2. That is S squared all over 2 plus. So we are going to multiply this by X over what? Over 3. So we are going to have W1 minus W2. Then we are going to have X over 3 all over what? All over 3 times 2L, that is what? 6L. So this will be our bending moment equation. So this is how to go about this derivation. So we are not drawing the shear force diagram and the bend moment diagram. Why? Because we don't have values here, but we can still sketch it. Do you understand? We are just going to use this shear force equation. Shear force equation, which is this, or you can use this. When S, you are going to start. When S is equals to 0, if you want to get the shear force at point A, you are going to say when S is equals to 0. So the shear force at point A will be equals to the reaction at point A. Then for you to get the shear force at point B, you are going to take your S to be equals to what? The O length. That is when S is equals to L. You are going to substitute in your shear force equation. Anywhere you have S, you replace it with what? With L. Then you get your value. All right. So from there again, you are going to recall that any point that we have our shear force equation to be equals to 0, we are going at that point we are going to have our what? Maximum bending moment. So we are going to equate this shear force equation to 0. Then we'll get the value of S, at which the shear force equation will be equals to 0. So when we substitute that value of S in our bending moment equation, we are going to get what? The maximum bending moment. Do you understand? At that value. Then again, we are going to get the bending moment at point A. That is at when the point where S is equals to what? 0. And the maximum bending moment, the bending moment at point B, the point where X is equals to what? L. We are going to substitute that there. Then we are going to have everything we want. Then we are going to sketch our graph. So this is how to go about this. But I hope we take one numerical on this. All right. Thanks.